Okay, so we are going to graph quadratic inequalities. When you graph a quadratic inequality, we're going to go through the same type of graphing we did before. So there's a couple of questions that you should ask yourself when you're doing this. The first thing is it going to open up or down? A is positive, so it's going to open up. Opens up. And is the vertex the maximum or the minimum point? Since it opens up, the vertex is the minimum point. And before we start to manipulate it, let's find that y-intercept. Because when it's in standard form, it is the easiest to find the y-intercept. Remember in section 4.1, the y-intercept is 0, c. So we're going to put 0, and which is c? What part of this is c? 4. So this is c, so I'm going to do that, and then I'm going to graph it. 0, 4. So I've graphed my y-intercept. Now in section 4.1, we found the axis of symmetry, then we plugged it in and found the vertex. Well, why don't we put it in vertex form since that's what we're doing and it's a little bit easier than finding that opposite. Let's put it in vertex form. So, y is less than or equal to x squared plus 2x plus a blank because we're looking for that blank plus 4 minus blank. So we're looking for those blanks. Okay, so to find the blank, we're going to take half of our b, which is 2. So half of 2 is 1. 1 squared is 1. And if we put a 1 here, a is 1, we can put a 1 here, and then we can rewrite that. Y is less than or equal to x. This is plus, so plus here. The square root of 1 is 1 squared, and then 4 minus 1 is 3. So my vertex becomes what is my vertex? If this is positive in here, what is it going to be here? -1, and then that's 3. So I'm going to graph -1, 3. So I'm going to go over to -1, up to 3. 1, 2, 3. In section 4.1, we learned that our axis of symmetry is actually the x point. So, and you told me it opens up, so that means my axis of symmetry goes up. Now, is this going to be a solid parabola or a dotted parabola? It's going to be a solid because of this, so it's a solid parabola. And what I mean by that is the line that we draw, the curved line, solid parabola. Okay, so that's another thing. Now, remember that for every point you have on one side of the axis of symmetry, you have a mirror image. So right here, my y-intercept is 1 away from my axis of symmetry. That means I have a mirror image on the other side 1 unit away. But what I want to do is I want to graph one more point. I just want to graph one more point so I have a really good idea of how my parabola should look. So I'm just going to pick a point on the right-hand side of the parabola and I'm going to plug in 1. So basically what I'm going to do is I picked an x, which is 1. You can pick any point. I just picked 1 because it was on this side. It's a small number. And I'm going to plug it into this equation. Don't plug it into the vertex form, plug it into the equation you started with to find out what the y point is when x equals 1. So what I'm going to do is I'm going to do 1 squared plus 2 times 1 plus 4. So 1 squared is 1 plus 2, because 1 2 times 1 is 2. So 1 plus 2 is 3. 3 plus 4 is 7. So when x is 1, y is 7. So when x is 1, y is 7. Well, 7's not on there, but you guys can get a good idea where it is. And 7 is 1, 2 away from the axis of symmetry. That means that I have another point 2 units away on the other side. 1, 2. And now I can draw my parabola. When you do this, it's an inequality. So remember that we need to shade. So there's 2 places that you're going to be able to shade. You're either going to shade inside the parabola or on the outside. So to determine where we shade, just like we did with the number line, with a line, we're going to pick a point, a test point. Well, I'm going to test 0, 0 since it's nowhere near the parabola. What that means by testing it is I'm going to plug in 0 for y and 0 for x. So I'm going to do a test right here. So 0 for y and 0 for x. And what we need to determine is this true? Is this equation a true equation? So is 0 less than or equal to 4? Is that true or false? So that's true. So we're going to shade where 0, 0 is. That means anything in the shaded region, anything outside of the parabola is going to make that equation true. Any ordered pair that we shaded, if we plugged into that inequality, it would be true. Any questions? Okay, so now what it says is we're going to solve each inequality by graphing. So we graph the inequality. Now we're going to do the same thing, except now, see how it says 0? Now we're going to use, we're either going to factor, we're either going to use the quadratic formula, we're going to do something to solve this. So the first thing that I like to do, you guys, is, because it really doesn't say, you can solve it any way. You could do completing the square. You could see if you could factor. My first inclination is always to factor because I'm good at that. But if you're not good, then you need to pick a one that you're good at. I notice 6 is a small number, so I can come up with those factors really easily. So let's do this one by graphing since it's equal. We're going to, let me write it. I want to write it the way you guys are used to seeing it. The mouth is facing the 0, so I just rewrote it that way because that's how we usually write it when we go to solve it. We are going to have to find the x and y intercepts. And then, because it's graphing, we're going to have to do a couple other things. So does this graph open up or down? It opens up, which means our vertex is going to be the minimum point. What is my y-intercept? So 0, -6. So let's go ahead and graph that. 0, -6 is down here. And then let's see if we can find our x-intercepts. Our x-intercepts are our roots. So I'm just going to see if we can factor it. Can you multiply 2 numbers to get 6 and add those same 2 numbers to get +5? So A is 1. B is 5, whoops, C is -6. what are the factors of -6 that can add up to? So I've got -1 and 6, and I got -2 and 3. -1 plus 6 is 5, so we're going to use that one, and basically what we're going to do, x minus 1 times x plus 6 is less than 0. So x minus 1 equals 0, x plus 6 equals 0. When you go to solve it, you guys, and this is going to be a dotted. So we get x equals 1, we get x equals -6. So we're going to put a dot on -6 and a dot, or point, I should say, on 1. And then we probably should find our vertex, right? Vertex is really important. So these are our x-intercepts, or these are our x-intercepts. And now we need to find our vertex. And really quick to find our vertex. Half of 5 squared is what? Well, half of 5 is 2.5, but square it is, it's 25/4, right? No, let's use a decimal because we can. Yeah, so we're going to put 6.25 here, 6.25 here. So it becomes x plus 2.5 squared -2.25. So our vertex is kind of down here, right? It's not on here. So 2.5, it's kind of down here. We're going to graph this. And then we're going to do a testing point. So we're either going to shade, so you guys, we're going to do some testing points. So we're either going to shade inside, and those are our answers, or we're going to shade on the outside. And so then I'll show you how to write it. And again, you guys, I'm really sorry this is bad, but you can see from our vertex literally is -2.5, comma, -12.25. So it's really below here. So it's not the best, but you can see that graphing isn't always the best way to do it, right? Because your graph has to be large enough to do it. Okay, let's test the point. Well, we've solved it. So now what we need to do is we just need to put, we need to test 0 and see if that makes it less than 0. And what did I do wrong, you guys? Oh my gosh, you guys didn't tell me. Did I? It definitely should have been, it should have been a dotted. It should be dashed, right? Because so what we want to do now is we want to test it. So we're just going to do a testing point. So we're just going to test, let's test 0, 0. This one is not too bad. is 0, if we plug in 0 for x, what do we get? Is -6 less than 0? So we're going to shade inside, and then I'm going to tell you, so that means anything inside. And tomorrow I will tell you how to, write it out. Okay, so this is what I want you to do for me tonight. I want you to graph number 3 for me. I know there's an assignment on it, but you guys probably won't be able to start it just yet. So graph number 3 for me tonight, and then on the back, we're not going to do number 4. On number 5, and number 6, I want you to find the x-intercepts for me. You guys can do that. I don't care if you complete the square, you factor, but find the x-intercepts for me. So tonight, I want you to graph number 3 for me. And number 5 and 6, you don't have to graph them. I do want you to find the x-intercepts. And x-intercepts are either you find them by graphing, which I don't want you to do. So factoring, completing the square, or the quadratic formula. Those are your 3 methods to find the x-intercepts. So I want you to graph number 3 and find the x-intercepts for number 5 and number 6. Okay? And then you can pack up.